Okay, so let's look at these problems. Okay, now half the battle now is to decide if you can use the binomial theorem or not. So let's see. Okay, you're gonna flip a fair coin 10 times, and you're like, up, I'm doing something again and again and again. So you're like, this is a total binomial theorem problem. Okay, so let's see. We want exactly 8 tails out of 10 times. So let's see. So the probability of getting a tails is 1/2. It has to happen 8 times. But then we have to get heads. And since they told us 10 times, that has to happen twice. And now we need our counter. Okay, so in the past years, this is what my kids had the toughest time with. Okay, so the counter is 8 times and 2 times. So you're like, that is 10 times. And out of those 10 times, we want 8 to be tails. Now, because of the ways combinations work, 10 times 8 is the same number as 10 times 2. So you could use either one, because choosing which ones are tails is the same amount of ways as choosing which 2 of them are heads. So if we just want to simplify this too, we've got 10 choose 8, and we would have 1/2 to the 10th. Okay, now if we want an equal number of heads and tails, we would have tails 5 times, heads 5 times, 10 choose 5, or whatever is equivalent. Okay, and now we've got that sneaky word, at least 9 heads. So that's 9 or 10. And these are separate paths, so we're going to have to add things together. Okay, so let's see. Out of the 10 times we're flipping, we want 9 of them to be heads. And now we notice since it's a 1/2 and 1/2, we'll just add those together. 1/2 to the 10th. And then we're going to do 10 heads. So that's 10 choose 10, 1/2 to the 10th. Okay, and what's nice is sometimes you can simplify these, like 10 choose 9 is the same as not choosing 1. So that's actually 10. And this one, 10 choose everything is just 1. So if you wanted to simplify it, I think that's 10 plus 1. I think that's 11, 1/2 to the 10th. Okay, let's look at the next one. Okay, so I've got 5 plus 4 plus 11. I've got 20 marbles I'm picking from. We're going to pick with replacement. So that means I throw the marble back in. So when I take a new marble out, I get the same chances of getting each of the colors again and again and again. And it doesn't matter what I picked the last time. So this one, a binomial theorem, is in play. If we do it without replacement, we can't use binomial theorem because when I take a marble out, it influences what my next pick is. So binomial theorem doesn't work there, but it works for the first one. Okay, so we want 2 red marbles. Okay, let's see how many times are we picking? 4. This time, let's get our counter first. So 4, choose 2, because out of my 4 marbles, my wins, can't see me, I'm doing air quotes, my wins are 2 red marbles. Okay, so let's see. So the chance of getting a red is 11, 20, it has to happen twice. So not getting a red is 9, 20, and that also has to happen twice. Okay, let's do the next one. So when in doubt, I think about a tree or I think about timesing. So let's see. I would need a red, and then a red, and then a not red, and then a not red. But I have to remember that if I do this, it's literally doing one branch, red, red, not red, not red, and I still need my counter because there's different outcomes here where really I have the same net effect, 2 reds and 2 not reds. So I totally need a counter here. Okay, and it's the same like the binomial theorem counter. I have 1, 2, 3, 4 events, and I'm choosing which 2 of them I want to have reds. Okay, so when I first pull, there are 11 reds out of 20. And then since I'm not replacing, I have 19 marbles, then I have 18 marbles, and then I have 17 marbles. Okay, so if I pull the first, I pick out 1 red, so I only have 10 marbles left that are red. And then when I start here, I'm just going to pick my non-red. So I think I'm starting with 9 of them. So 9 and then 8. Okay, let's do the last one. Okay. I don't know why this is showing for you. Okay, so let's just write a function. Okay, so we're going to do a multiple choice. It's got 10 questions. So we're going to guess 10 times. And I want to get 50%, which means I need 5 right. So I know my counter is 10, choose 5. My chance of getting a right one is 1 out of all my choices. That has to happen 5 times. So I know guessing wrong is 1 minus 1 over x. And if I guess 5 of them right, I guess 5 of them wrong. So if you put this into y1 and check out your table, I just scanned through my table and it got less than 100% when I got to the 7th entry. All right. Good luck on your homework.